Let us look into this problem now. The question says, a boy jumps off a high diving board above a swimming pool. Halfway between the board and the water, he tosses a ball upward. Ignoring air friction, the instant after the ball leaves his hands, the vertical component of the acceleration of the ball is A positive but then decreasing through 0 to minus 9.8 is 0 but then decreases. So these are the choices A, B, C and D. This is said, let me write for you. This is meter per second square. This is the diving board. This is swimming pool. The boy jumps from here. When he was halfway in between, he tosses the ball up. He tosses this ball up. In question, it is being asked, what will be the acceleration of the ball just after the ball leaves the boy's hand? So what is happening? Like when your ball just leaves the boy's hand, it comes under the gravitational field and under the Earth's atmosphere. But air friction is saying that it is to neglect here. So what is happening? Only one force is remaining, and that force is gravitational acceleration, that gravitational force. And how much acceleration does the gravitational force creates is G, and that is working downwards. This is 9.8 meter per second square. So our axis is vertically up for the positive direction. So G will be minus 9.8 meter per second square if we take it in the negative direction of the y-axis. The y-axis, like vertical axis, if you have taken this way, positive. So G is acting negative. So D will be your answer. So don't confuse with any other is positive but then decreases through 0 to 9.8 meter per second square. What is, see, when the boy is coming down and when he throws the ball up, so whatever velocity it imparts to the ball in the vertical direction, that will remain associated with the ball at that instant, but the acceleration, the force, because it left its hand and now it is under only one force, that is gravitational force, because air friction is saying to neglect. So only one force is present, gravitational acceleration, gravitational force. So it will experience an acceleration of g is equal to minus 9.8 meter per second square, which is acting downward. But our axis is positive, our positive axis is up. So we can say that the acceleration will be minus 9.8 meter per second square. So D will be the answer. Now let us go to the next part. Next question. A small toy looks like a pipe and shoots a marble out each end. So suppose this is the toy. It looks like a pipe and it shoots the marble downward as well as from top and from the bottom, both sides. That's what it is saying. The toy is dropped out of a tree. So let us say this is your tree, and the toy drops out from there, coming down with g acceleration. The toy is dropped out of a tree and fires halfway to the ground. When it is halfway from the ground, it fires the marble, one from bottom, one from the top. One marble shoots directly up and one directly down. So consider the vertical component of the acceleration Ay. The vertical component is your Ay in this direction of the marbles. Immediately after the marbles leave the toy, ignoring air friction. Again, the air friction is not present. So only one force present is the gravitational force, and that will accelerate the marble downward with 9.8 meter per second square. So the upward moving marble has Ay less than minus 9.8 meter per second square. So this will be wrong, because only force which is acting once it leaves, once it comes out of the pipe, due to whatever mechanism by which it has been thrown out, once it leaves the contact of the pipe from that mechanism, it is exposed only to the gravitational field. So only the gravitational acceleration will work on the upward marble, the marble which is going upward, and the marble which is going downward. So in both the cases, the acceleration will be g is equal to 9.8 meter per second square in magnitude, but the direction will be downward. So it cannot be less than minus 9.8 meter per second square. So A is wrong. The upward moving marble AY is equal to minus 9.8 meter per second square, which is right. This minus sign has come because our positive direction is up, but actual acceleration is working in g is equal to 9.8 meter per second square downward. So negative sign has been introduced here. So B is correct. The upward moving marble has AY. No, this will be wrong because it will be under the acceleration of 9.8 meter per second square in magnitude in the downward direction. Only force act on the marbles will be the gravitational force. So C is also wrong. The downward moving marble has AY greater than minus 9.8 meter per second square. This will also be wrong because it is saying immediately after the marbles leave the toy. So once it is out of the mechanism of throwing the marble from the pipe, it is exposed only to the gravitational field, and gravitational force only will act on that, on those marbles, and acceleration will be g, 9.8 meter per second square in magnitude, acting downwards. So D also will be wrong. So your answer will be B.